Good afternoon, everyone. Welcome to the Mind Action Series Mathematics webinar on functions. My name is Roselle Lowe, and I'm the sales manager at Mind Action Series. Our presenter today is Jurg Passon, one of the co-authors of our mathematics range. And you all would have received the notes via email to follow along. If you haven't, then just pop us a message in the chat box with your email address, and Anita will send it to you. If you have a question, please type it in the chat box, and I'll notify Jurg that there is a question to be answered. We will be recording the webinar and share it with all the attendees afterwards. So if you have to leave earlier, you won't miss out. There will also be a 5-minute break at 4 o'clock for Jurg, just to stretch his legs. So feel free to do so as well. Thank you. Enjoy the webinar. Over to you, Jurg.
Thank you, Roselle. Good afternoon, everyone. It's always nice to discuss some mathematics with you again. Our topic for today is grade 11 functions. So I really want to focus on the graph interpretation. I prepared some information for you and some notes for you, which I will go through. I realized only afterwards, but I don't think it will be a problem for you, that I think I've got too many problems and I don't think we will be able to cover all of them. But if you don't mind, there are easy stuff in between which we can maybe do a little bit faster. So, but I will ask you if you can just give me a thumbs up if you're happy that we concentrate on I want to say the more important stuff, difficult stuff, and so on. But in any case, ladies and gentlemen, first of all, I included this page. This is all these examples and problems are from the grade 11 Mind Action textbook, the new version. So you will, if you have that new version, the new edition it's called, then you will find all these problems in that textbook in functions. And if you're interested in those, you can always make contact with Roselle for those 10, 11, and 12. We have a new series available. So, ladies and gentlemen, first of all, what I find quite important is to discuss with the learners what I like to call the mother functions. And I always make a little bit of a joke. Now it's so difficult to make jokes because I can't see you. But in any case, I always say to the grade 12s, if I discuss this with them, then I say, you must just say it slowly. It's mother functions. Otherwise, if you say it too fast, it may sound quite like a very terrible word. So just on a lighter note. So there you can see all the mother functions. And I would like to discuss with you a little bit, if you allow me 15 minutes or so, just to talk a little bit about these mother functions. It is really important that your learners must know these equations, this y equal to x squared, as well as the drawings. Because we now, after this, we're going to add the parameters, the A, P, and Q is what we add in the CAP syllabus. And they must be able now to draw those graphs, but they must do it with reference to the mother functions. So they must know what those parameters do to a specific graph, and they will then be able to sketch those graphs. And then finally, we will get to the graph interpretation. That's now the inequalities and those questions on inequalities and nature of roots. That is what I was looking for. So if I can quickly start, I've got a few blank pages, so don't worry, it's only so that I can write. So the first one is this y equal to x. Now I don't know why my pen don't want to write, but I think I will get it. Let me just see what is going on. Hey, ladies and gentlemen, I'm sorry. It looks like every time there's a little issue and I don't always know how to fix it. And this thing, ladies and gentlemen, I'm really sorry. I don't know. My pen don't want to write on my iPad. And I checked everything, and now when I want to start, it doesn't want to write. So I don't know what I must do. So if you just bear with me for a moment, please, sorry.
Okay, so while Jurg is sorting it out, yeah, I think maybe you guys can, in the chat box, let us know where you're from. And yeah, let's just give Jurg a bit of time to sort that out. I think he might be on the phone to his son just to get him some help. So yeah, just in the chat box, let us know where you guys are from.
All right, it looks like I'm back. I'm sorry for the little bit of a delay. There you can see we're in business. So it's at least now it's writing. My pen didn't connect properly to the iPad, and that was the reason. But always never a dull moment. Y equal to x, the straight line graph. We also refer this as the linear function, and very straightforward. Why a straight line looks like this, the y equal to x. I don't think I need to explain it, because if x is 1, y is 1, and that is why the equation y equal to x. What I rather would like to quickly focus on is what happens to a straight line graph if you square it. Now, I know you maybe think now that is the parabola, but for the sake of discussing it, in particular, if you introduce this in grade 10 and you can introduce it in 11 again, is I like to talk about if you square the linear function, you get a quadratic function. And this is a linear, and what will happen if I square it? And this part of the graph will move up. I think you will agree, because the moment I square something, it is always positive. So there can't be any graph below the x-axis. So this graph must go up. So just to have a quick idea how it will look like. So we've got this part, and then the part that was in the third quadrant, we expect to move to the second quadrant because it must be positive. Now the question is this a turning point or is it a vertex point? And that is now the interesting thing if we look at what happens at 1. Now, if I can just remove these two lines. So if I go to 1 and 1, you will agree on the straight line I get if x is 1, y is 1. On the square, I also get when x is 1, y is 1. So it almost gives us the idea of the same thing that happened in the straight line will happen here as well. But the interesting thing is we must have a look at a half. If we put a half into the equation, you all agree we get a quarter. So that means that point is lower. And that means this graph is going to curve. And the same thing happens to the negative side of the x-axis now. And that is where we get the shape of the parabola, is because of the square. It's just, I think it's interesting and quite important for learners to know. Then I also look at the reciprocal function. And that then we focus on reciprocals. In grade 8 and grade 7 and 8, I think we discuss reciprocals with the learners. And they must know a reciprocal means that if you want a reciprocal of 2, you get a half. Reciprocal of a half is 2. Reciprocal of negative a half is negative 2. So a negative stays negative, a positive stays positive. But the moment you find the reciprocal, the function becomes decreasing. So wherever it was increasing, it will become decreasing. And the reason is for the fact that the reciprocals become smaller. So if I just start to draw a graph, then I will explain. So first of all, because x is below the line, we refer to this as zero denominators. And there is a possible zero denominator here of x equal to 0, which is undefined. So that means that is an asymptote. So the y-axis is an asymptote. And so the x-axis will be, but I will get to that one. So if we now start to look at this graph and I substitute x with 1, I'm not going to work with 0, but if I substitute x with 1, you agree y will also be 1. So it looks like the graph will be there. But now what happens to the right? So if we go to 2, for instance, you will agree then y will be a half. And 3 will give a third, and 4 will give a quarter. And if we go to a half, we will get to 2. And there you can see the graph is decreasing. Note that the parabola was increasing, the straight line was increasing, but the hyperbola is decreasing for the reason that it is a reciprocal function. And the same will happen in the third quadrant because a negative stays a negative. It's not like with a parabola where a negative becomes a positive. Here, a negative stays negative, but the same principle will happen. The last one that I quickly want to discuss with you is y equal to 2 to the x and y equal to half to the x. Also take note that this half to the x, the examiners in grade 12 and in 11, they quite like sometimes to write it as 2 to the minus x. And some learners get confused with that because they look at the base of 2 and they think that this is an increasing function. And they don't see that negative that is with x. So 2 to the x, that is the increasing one, and it intersects at 1 on the y-axis. And the decreasing one also intersecting at 1 on the y-axis, but just decreasing. The two mother functions of the hyperbola. Now, again, this hyperbola has got an asymptote, which is the x-axis. And the reason is very simple. Why is there an asymptote? Because we need to determine is there an x-intercept. So that means we're going to substitute y with 0. So we get 2 to the x is equal to 0. So that is the question we face. is there a possible value for x that will change this whole thing to 0? And the answer is for sure not. A base of 2, doesn't matter what the exponent is, will never be 0, because if it's a negative base, a negative exponent, it will become a fraction. Positive exponent, it will become bigger. 0, x is 0, it will become 1. So there is no solution for x, this particular one, and that is why we've got an asymptote. And almost a similar reason, I didn't mention it on the hyperbola. I mentioned that the y-axis is the asymptote, and that is because of the x below the line. But the x-axis is also an asymptote, and the reason is that the same thing, if we write down 1 over x is equal to 0, because we are looking for a possible x-intercept, we want to know what x must be. Is there any possible answer for x? And the answer is no. There is no solution that will change this fraction to 0. And there's a very important reason for that. Ladies and gentlemen, if we have k over 0, that is undefined. And that's what we already spoke about. But k is not 0. But if you have 0 over k, your answer is 0. So very important, a fraction can only be 0 if the numerator is 0. And a fraction is undefined if the denominator is 0. And that is the reason why hyperbola has got two asymptotes, x-axis as well as the y-axis. So I want to say a few things more about the exponential function, because I would like to start now with the parameters. And the first one is when we have y equal to a to the x, and y equal to ax squared, and y equal to a over x for the hyperbola. And then for the exponential, we will say y equal to a times b to the x. So these are all the a parameters on all four of them. It's important the learners must understand what happens to the graph, what happens to the linear, the straight line, if I change a, to the parabola if I change a, to the hyperbola if I change a, and to the exponential if I change a. Now the straight line, you will all agree with me, change the gradient. So if it's positive, the gradient is increasing. If the graph is increasing, if a is negative, it's decreasing, and pretty straightforward. The parabola, the ax squared, if we put a 2 or a 3 there, so 2x squared, 3x squared, the graph will become narrower. But if you make it like a half or a third, the graph will open up, the parabola. The hyperbola, the a over x, that a, the only important thing about that a, if it's 2 or 3, it doesn't have a massive effect on the graph. It only changed the curvature of the graph slightly. It doesn't really bother us that much. The main thing about that a is when it is negative. And also with a parabola, if it is negative, then it is the sad face parabola that goes down. With this one, if it's negative, it swaps quadrants. So it's a reflection where it is first and third quadrant, it will swap to 2 and 4. So we can see it as a y-axis reflection. We can also see it as an x-axis reflection. So both are applicable to this one. So that is the a, what a do to each one of these functions. Then we have a q parameter that we add. So now it's y equal to ax plus q, and y equal to ax squared plus q. And this one is a over x plus q, and this one is a times b to the x plus q. And this q moves the graphs up and down. Now this is up to where you must go in grade 10, up to these two parameters. And then in grade 11, we add the P parameter, and that is the horizontal shift. And that is where I would quickly like to discuss a few things with you when we start with that horizontal shift. So I think this is all, you're all comfortable with this, I believe. The straight line doesn't have a P parameter. We only have the A and the Q, because we can only change the shape, that is the A, and we can shift it up and down. And if you shift it up and down, it moves left and right in any case. But we're going to focus on the other three, the quadratic, the reciprocal, and the exponential, when we look at the parameter of P. So let me just remove some of this. And then we say y is equal to a bracket x plus p squared plus q. That is the parabola with all three of them. Now, ladies and gentlemen, I've got this question many times, that when we have a problem, let's say it is 2x plus 1 squared minus 3, just to write something down. You will agree when we look at this equation, the 2 tells us something. It tells us that the graph is narrower than the mother function. The minus 3 at the end means the graph moved 3 units down from where the turning point used to be at 0, 0. It's now at 0 minus 3 because we move it down to negative 3. And then we look at the bracket, and that is x plus 1. My suggestion is what I tell the kids. I say, take that bracket, put it equal to 0, and solve for x. And then you know the shift. And that graph will shift 1 unit to the left. And this is, for learners, quite confusing. Because when we look at the q, that negative, we stick to the negative. If it's minus 3, we go down. If it's plus 3, we go up. But with a p, it works differently. And there's a reason for it. And the simple reason is this negative 3 is a change in y. So it is supposed to be there. I'm not saying you must put it there. We always take it across. But if I just write it down on that side like this, you will see what I'm trying to say. If I now want to know what the vertical shift is, up and down, I must take y plus 3 and I must put it equal to 0, and y is negative 3. Then I know it's 3 units down. And then I take x plus 1 and I put it equal to 0, and x is minus 1. So it's 1 unit left. Now we don't write the equations like this. We always want to manipulate y. Only reason why I explain it is because people ask me, why does it work differently? The q works with the sign and the p works against the sign. And what I'm trying to tell you, they work the same. It's only because we manipulated y to get y alone, and that constant was moved across. Remember, a vertical change is a y change. So that's why the negative 3 belongs to y. But please don't tell your learners to write it like this. They will become totally confused. It's only if you feel like you want to explain if your learners ask you about this. And that was the reason I just wanted to show you. When I go to the hyperbola, and I go 1 over x plus 1 minus 2, for instance. So this is now a hyperbola. You will notice the quadrants are not going to change the shape of the graph because the numerator is a positive 1. But we have new asymptotes now. So that y equal to minus 2, this negative 2, that is your horizontal asymptote that will cut the y-axis. And then this part below the line that makes the denominator a possible 0 denominator. And then you say x plus 1 is 0, so x is minus 1. So x can't be minus 1. That is why it is an asymptote. And now they must first draw the asymptotes. So we go minus 1 minus 2 for the horizontal, and x equal to minus 1 for the vertical. And then we know the shape will stay the same as the mother function, and we can sketch it between those two asymptotes. and then, of course, between these two asymptotes. This particular one, you notice that there will be now a x and a y intercept, which the learners must now find as well. So just a little bit of that. This is still not too difficult. I want to finish the discussion with the exponential. And as you can see, an exponential function has got 4 parameters, a, b, p, and q. So that b is the base. So I want to start there. If I start with 2 to the x again, and we just quickly sketch that graph, which looks like that more or less, then I quickly want to see and that we have a look at what will happen if I change a. So I say 2 times 2 to the x. So I put the a in front of it. Now, if I sketch this graph and I substitute x with 0, we know this graph didn't shift. So the x-axis is still the asymptote. But when I must find the y-intercept, and if x is 0, I get 2 to the 0 is 1 times 2 is 2. So it means this graph is going to intersect at 2. And then we can draw it. And I always ask the learners, what happened? And do you know that majority say to me the graph moved up because it intersected at 1 and now it intersected at 2. But it didn't move up because you can see here on the negative side, they both tends to the x-axis. So if a graph moves up, the whole thing must move up. So they must almost be like parallel. And this is not what happens. This is a change in shape. This graph got steeper. Now, my drawing is not extremely accurate, but I'm going to try to show you with my finger. Oh, no, this is not going to work. Okay, let me see what I can do. I want, if you look at that point, if you can see it highlighted in red in this one, I want to put a finger on this point and a finger on this point, and I want to move it 1 unit to the left like this. And if I draw those lines in, you will notice that if I move this graph 1 unit, it will fit on that graph. If I move it 1 unit to the left. Now, why do I get that from? And it is this. You see that is 2 to the 1. And that gives you 2 to the x plus 1. Can you see that is a horizontal shift? And that is what is extremely interesting about the exponential function. It's the only function of its kind that we do where the change in A, the effect that A's got on this graph is similar than the horizontal shift of 1 unit to the left. So the graph became steeper. It was not a vertical shift. So it's just something I wanted to mention. Please remember, if we have y equal to 2 to the x plus 1, say minus 1, for instance, then it means this graph moved 1 unit down. So the axis, the asymptote was the x-axis. Now the asymptote is at minus 1. And now we want always, when your learners sketch this, tell them to find the asymptote first, and that you get from the Q. Secondly, they must find the y-intercept. That is where x is 0. And if you substitute x with 0, you agree I get 2 to the 1, which is 2, minus 1, which is 1. So this graph, that is 0, this graph will still intersect at the y-axis at 1, but now you most probably notice it will also have a x-intercept. The y-intercept is at 1, but it will also have this x-intercept here. And that is when 2 to the x plus 1 is equal to 2 to the 0. That one you write is 2 to the 0. So x plus 1 is 0, so x is minus 1. So that value minus 1, and the learners must find those intercepts. So ladies and gentlemen, if I can quickly recap, I just want to highlight a few things. When we look at the APQ form of the parabola, that bracket, the x plus 1, if we solve it at minus 1 and minus 3, that gives us the turning point of the parabola, the minus 1 and the minus 3. So the P and the Q, it plays a vital role when we work with parabolas. It really helps us. When we get to the hyperbola, the P and Q are also extremely important because that gives us the asymptotes. And we can't sketch a hyperbola if we don't have the asymptotes. They first need to find the asymptotes, draw the asymptotes, and then they find possible x and y intercepts, and they sketch the graph. So those are the critical points in terms of a parabola, in terms of a hyperbola. And then in terms of an exponential, keep this in mind that it is quite an interesting graph, quite different to the other three. The straight line, the parabola, and the hyperbola, they sort of family of one another because they're all algebraic. But this is an exponential function, which is part of a different group of functions, where also the logarithmic functions belongs to the exponential functions. You will know in grade 12 we find the inverse of the exponential, which gives us the logarithmic. And that is a pool of functions, all the exponential and logarithmic functions. We don't do it so at the same way at school level, but I think it's good that learners must know there are different groups of functions. We have the algebraic ones, that is the x to the n in terms of calculus, and that is y equal to x, y equal to x squared, y equal to 1 over x, that is x to the minus 1. So we have all those are algebraic, and then we have the exponential functions and logarithmic. That is what we refer to as the transcendental functions. And then we have logarithmic functions. That is part of this. And then we have the trig functions in paper 2. That is another group of functions. So I hope this was not a waste of your time. I just wanted at least to give you a little bit of a background on why functions look like this. I don't want to waste time, but I want to quickly show you something. I was referring to the trig functions. And if we look at y equal to tan x, I just want to show you something that I quite like to do when I discuss this with learners. I ask, I think, thousands of learners, which are one of the three trig functions you hate the most? And all of them say to me, all three. I said, no, you can only choose one. And everyone will select tan. Because tan is a weird graph. Sine and cos are continuous functions. Tan is not. Tan is quite a weird one. And the reason for it is because it's not the real name. The real name of the tan graph is sine x over cos x. So this is a rational function. And the interesting thing about this is also a rational function. It also has a fraction. That's why we refer to them as rational functions. So there are possible zero denominators. So let's pretend you've never seen this graph. And let's take 2 minutes and we quickly build it. So if I want to draw this graph, I've got no idea how it's going to look like. Then I do know if my numerator is 0, so that means if sine x is 0, then I will get x-intercepts, because then the whole fraction will become 0. You remember the fraction that I said 0 over k is 0? And that is the reason. So if sine x is 0, the whole fraction is 0, and that gives me the x-intercepts. And can you see where the x-intercepts are? Where sine is 0? So at 0, at 180, and at 360. That is where this graph will cut the x-axis. Now, what about if the denominator is 0? You agree, then I get undefined answers. And in a function, if a value is undefined, it gives you an asymptote. Remember, in the hyperbola, what made this fraction undefined? If when x was equal to -1, and that is x equal to -1 is an asymptote. It's not part of the domain of the function. And that is what we are now focusing on here. So I just quickly want to draw a tiny little cos graph. And do you notice that is where cos is 0, and that is at 90 and at 270? And you can now see why I do it like this, because I want children to understand why a tan graph got asymptotes and sine and cos doesn't have. And that is the reason why there are asymptotes, because tan is sine over cos. So I like, in terms of a drawing, for them to understand why the tan graph looks like this, is to look at sine over cos. Now we need to see how is this graph going to look. So you will agree it's going to cut here at 0. It can't intersect the asymptote at 90. So it can either go up or it can go down. There's no other way. It must be one of the two. Now, the interesting thing is to know which one. We just look at the sine graph quickly. And do you notice there's the first quadrant, and sine is positive, and cos is also positive in the first quadrant. So that means sine over cos will be positive. So that means the graph will be there. It will be positive. Now, if you look at the second quadrant, 90 to 180, you will see sine is positive, but cos is negative. So that means the quotient is negative. So that graph will be negative. That means below the x-axis. Ladies and gentlemen, I refer a lot to a graph positive, a graph negative. The reason is those questions are coming. Where will this graph be positive? Where will this graph be negative? So it's quite important that as you discuss it, that you always talk about it, and they must understand a graph above the x-axis is positive, a graph below the x-axis is negative. Let's quickly jump to the third quadrant. Third quadrant, sine is positive, a negative, cos is negative, so the quotient is positive, and that is why the graph will be positive. And then, of course, the third one, the fourth quadrant, that is not negative, a positive, that must be negative, and that is negative, and this one is positive. So that means the quotient will be negative. And there you have the tan graph. So ladies and gentlemen, just an understanding, just to explain this basic graph to your learners. And I just wanted to show you a little bit of that. All right. So now I've got another page here. These are now the transformations of functions. You will recall in our previous syllabus before CAPS, we did transformations as a separate topic in paper 2, but that was removed with CAPS, and we shifted only to functions. So we don't do all of the transformations, but these transformations on functions your learners must be able to do. Now you will notice the very first one. If I can just highlight this one, you will see this is what we call a translation or a shift. So it's a shift up and down or left and right. Now, if you look at this notation, do you notice the Q is the Fx plus the Q? So that is a vertical shift. And this one, you see the change is with X. It's X plus P inside the bracket. And that is the horizontal shift that we have there. So that is your shifts, but the notation tells you what it is. If you look at these two, these are reflections. A reflection in the x-axis, a reflection in the y-axis. So if we reflect in the x-axis, you agree with me, y becomes negative, and that is why we've got minus fx. But if you reflect in the y-axis, x becomes negative, as you can clearly see. And then I spoke earlier when we spoke about those mother functions, and we add a to all of them. That is the a fx. Now, that is a change in shape. That's what I call it. but we also refer to this as stretch or squash. If you don't want to use the terminology, I just use the change in shape. But if you think of the parabola, if that A is 2, 3, or 4, the graph is narrower, so that means we stretch it. And if that A is a fraction, like a half or a quarter, we squash the parabola so it opens up. So that is where this terminology is coming from. So just be aware, we are going to do these transformations now when we start some problems. This is the interpretation of graphs that starts here. You will see I just gave you all the different possible inequalities the learners must be able to answer. Fx greater than 0 above the x-axis, fx less than 0 below, fx greater than gx, fx less than gx, and then the product less than 0 greater than 0. And so let's move to our first problem. So ladies and gentlemen, I prepared, if I remember correctly, 10 examples for you, but all of them have sub-questions. So it will take quite a time, but some of these, like this first question, you will notice the equation of the parabola is now given to you, but in the 3-term form, the ABC form, not the APQ form. Learners must be able to work with the parabolas that way as well, or alternatively, they can take that equation, complete the square, and change it to APQ if they want to do it. I normally suggest, my opinion is, if it's given to you in APQ form, you use it. If they give it to you in the 3-term form, you use it like that. I don't think it's so difficult, but it's up to you. The first question is, they ask us the length of AB. Now, to find the length of AB, you will of course realize that is where A is and that is where B is, and those are the x-intercepts of the parabola. And I'm sure all of you can find those x-intercepts, so I'm just going to write down those x-intercepts. So that is when x squared minus 6x minus 7 is 0, and we quickly find those. And it's 7 and 1 minus and plus, so x is 7 or x is minus 1. So we've got minus 1 and 7, so that means AB will be 8 units. You all agree, because that minus 1 only shows the position from OA is 1 unit and OB 7 units, so a total of 8. Coordinates of C, nothing really difficult to find. That's the y-intercept, which was given to us as minus 7. So C, important thing is, they must write a coordinate. They ask for coordinates of C, so they can't just say minus 7. If we quickly look at the A and the B, you will agree with me that is the equation of the straight line. I just want to put those values in. And if we look at the equation of the straight line, we do have the x-intercept of the straight line, as you can clearly see here at B, and we have the y-intercept of the straight line right at C. And the equation of the straight line given to us here was y equal to ax plus b. And I think you all agree with me, b will be minus 7. Because that we know from the previous question. That is the y-intercept. So we must now find the gradient. So we can use the gradient formula, that y2 minus y1 over x2 minus x1. Or we can just substitute the point. And we can say that y is equal to ax minus 7. And we use the minus 7. So let's substitute 7, 0. So y is 0 and 7a minus 7. Because our x is now 7. Is that correct? Yes. So that means a is equal to 1. So therefore, our equation is x minus 7. So a is 1 and b is minus 7. The coordinates of t, that is the turning point. Ladies and gentlemen, for grade 11, of course, the turning point we use minus b over 2a. And the answer of that one, if I can just quickly write it down for you, will be 3. Then we save a little bit of time because it's only to substitute B and A. We substitute the 3 back into the given equation to find the y, because we want the turning point, and the y is minus 16. So that point T is the point 3 minus 16. So that is 3, and down here at minus 16. Now they ask us for the length of PT. Now, if I want the length of PT, I just want to highlight that length. It's right here. Now, if I want that length, you will agree, we know this point here is 16, but we don't know that point at P. So we need the y value at point P. We know the y value at T. Now, P is on the straight line. So the only thing we need to do is to take the 3 of x is 3, put it into the equation of the straight line, and that will give us the y value. So we will say y is equal to 3 minus 7, which is negative 4. So that value is at negative 4. So what is the length of PT? PT goes from negative 4 to negative 16. And I think you will agree with me that is 12 units. Remember, we can just say 16 minus 4 because the negative only shows where it is on the Cartesian plane. I don't think there's any problems here. These are still quite easy stuff, straightforward. We need to find many of these values for the questions coming. So I will just write them in as we go along. They ask us now for the length of QR if QS is 18. Now you will remember we get questions where they ask us for a maximum length of QR. In this case, a maximum length is not going to work, not where QR is at the moment. But now they give us the length. They ask us the length of, sorry, let me first say, I say QR, I mean OR. And we want OR, which is a horizontal distance from 0 to R, that distance. So we need the X value. But they gave us the length of QS, this whole length here of QS, they gave us that length. So how do we find that length? A distance between two graphs, always we subtract them. So we will say to find the length of QS, because it's given to us as 18, but we must also say it is the parabola, which is x squared minus, was it 6x, I think, minus 7, and we subtract the straight line, which was x minus 7. And if we simplify this, I get minus 7x, minus 7 plus 7 will be 0, that is QS. But QS is given as 18. So we can say x squared minus 7x is equal to 18. So x squared minus 7x minus 18 is 0. We factorize and we get x 18. That gives you the 7 will be 9 and 2. And 9 must be negative and 2 must be positive. So x is 9 or x is negative 2. All right. I just want to see that's a minus 18. I don't think I've made any mistakes. This one is not applicable. We are interested in x equal to minus 2. So I think you will agree with me. We can now say OR will be 2 units because this x value here is at negative 2. That means OR 2 units. What is the range of f? Parabola, the range always from the minimum up to infinity or from maximum to negative infinity. That is the y values. So the range of f will be y greater equal to minus 16. Or we can say y is an element of minus 16 up to infinity if we put it in in interval notation. Just want to just say why is an element to that. Now we're at the inequalities. And that is where I would like us to focus for a moment. Ladies and gentlemen, there are two of them here. The one you will notice the inequalities between the two functions, f and g. The other one is a product. They can also give it as a quotient. Now, let's start with the one between the f and the g. There can be fx greater than or fx less than. Now, to know where will this happen is we need to know where is fx above gx, because they ask us that fx must be greater than gx. Don't confuse it with the x-axis. I'm not saying it must be above the x-axis. F must be above g. It doesn't matter if they are above or below the x-axis. We want to know where on this graph we will get that. And ladies and gentlemen, this will happen at this kind of thing happens exactly where the two graphs will intersect at B and at A. Sorry, not A, but C, B and C. Because the moment the two graphs intersect, their position changes. So it will change. So if F was greater than G, then they intersect, then G will be greater than F. And if they intersect again, then F will be greater than G. So my suggestion is that we draw vertical lines, and we draw it at, and I'm going to do it in blue, at the point or points where the two graphs intersect one another. And that is at point C and at point B. That's where they intersect. Now, the reason why I like to draw these vertical lines is I want the learners not to look at the whole graph at once. I want them to look at the intervals. So if we now look from zero to the left for that, we want to know which graph is above which one. You see, there's the one, this is the G, and there is F, and there is G. And you can clearly see F is greater than G. So this part we want. So we're going to write this down. So we're going to say this will happen when X is less or equal to 0. I put the equal because there's an equal in the question. But I must now also look for maybe another possibility. So this is the first one. That is the part from 0 to negative infinity, this interval. Now I'm going to look in between the two blue lines right here. Now, if I look at that interval, we expect the order to change because they intersected at 6, at point C at -7. Do you now notice that the straight line G is above the parabola? And that is not what we want. That would have been the answer if in the question that was a less. Then the answer was between 0 and 7. Now we need to look at after B, after 7, that way. And do you notice that is where F is, and that is where G is, and F is above G. So that means we have another solution. So we say or X greater equal to 7. And I really hope that makes sense. That is the way I prefer to explain it to learners, to say, if your inequality is between the two functions, fx greater or less than gx, you draw lines at the points of intersection of the two graphs, and then you look at the different intervals. Only thing to keep in mind, if these questions, and I have one like that, when it is a hyperbola, you also draw the lines at points of intersection, but you also draw a line at the asymptote, because it will also, the interval will break at the asymptote because that is not part of the domain. if we look at the number 2 for this one, then I want to draw lines again. So I'm just going to remove these blue lines for a moment. And that we just start again. And let's do it in red. So this time it is fx times gx, as you can see. Now, fx times gx means a product. So, and we want the product to be negative. So for a product to be negative, we want to multiply a negative with a positive or a positive with a negative. And both of them will give me a negative. Now you can see now it's about positive and negative. So it is above the x-axis or below the x-axis. So when a graph cuts the x-axis, the sign changes. If you look at this straight line here, can you see this part of the line is negative? Then it intersects, and then it becomes positive. So the sign change at the x intersects. That is where the signs change. So we must now draw lines at the x-intercepts. The first x-intercept is at A, so I'm going to draw a dotted line here at A. Remember that value was at -1, and the second one is here at 7. And now we're going to do the same as what we did on the previous one. We're going to look at these 3 intervals. So from -1, I'm now going to look to the left, and I want to know, is one graph above the x-axis and the other one below? I don't care which one is above, which one is below. And you will agree with me, up to that point of intersection, the parabola is above and the straight line is below. So we want that. So that solution we want to write down. So we're going to say x less than -1. We don't put an equal here because there is no equal in the question. That is the first interval. Now we're going to look at the second interval. This is from A to B, from that interval. Do you notice there's the straight line and there's the parabola? They are both negative. That means the product is positive. So if that question was greater than 0, then the answer would have been between A and B. Now we look at from B to infinity. And do you notice from B onwards, G is positive, F is also positive. So the product is positive. So that means that is our only solution. So I hope this is at least a good start with these. There's still 2 little questions left on this. And that is now to find the coordinates of the turning point if we apply those transformations. And we notice what I said to you earlier. The exam panel said 2 years, 3 years ago, these transformations will be in every question. So this turning point of this graph is at this point, which was 3 minus 16. You'll remember that it is 3 minus 16. So that was the turning point. So I just want to write it down, that our turning point is the point 3 minus 16. So what they say now to us, they say, apply this transformation and give us the new turning point after you transformed. Now, this transformation, very clear, this is a horizontal shift. And like we said before, we take x minus 2, put it equal to 0, so x is equal to 2. So that means the parabola will move 2 units to the right. 2 units to the right. This is where it is at the moment at 3, and it will move 2 units to the right. So you will hopefully agree with me that this new turning point will be at 5 minus 16. Remember, the 16 and negative 16 will not change because we didn't move it up and down. So that is our horizontal shift. Now they want the coordinates of the turning point. If we reflect it in the y-axis, if you look at this, you will notice that this refers to a y-axis reflection. Now, if I reflect in the y-axis, then x becomes negative. So that means what will the turning point be? Remember, the turning point was 3 minus 16, but now we reflect this turning point in the y-axis. I'm sure you agree it will become negative 3 minus 16. And if we look at the parabola, you see that distance 3 units, it will be 3 units that way. That is where we want to move it. And that means it will be at negative 3, and that turning point will stay at minus 16. So these are the kinds of questions your learners must be able to answer. Ladies and gentlemen, the second question is a hyperbola with a straight line. This was a parabola with a straight line. So I want us to do at least all different kinds. These are still the same question. Then I have another one on a parabola with a straight line, which I think we can maybe leave, if you're okay with that. And then we have two exponential functions that I would like us to discuss. And then we can take it from there and see what we can still fit in. I think before we start this example 2, ladies and gentlemen, I just quickly want to get myself a glass of water. I will be only a few minutes. So if you want to stretch your legs and get yourself something to drink, let's take 5 minutes and I will see you in a few minutes.
Afternoon, everyone. Those who just joined, we had a couple of people who joined us a bit late. Jurg is just taking a quick break. We'll reconvene within a few minutes. And please also just remember we are recording and we will share the recording with you afterwards, as well as the notes. Again, for those who just joined us, Jurg is just taking a quick break. We'll reconvene within a few minutes.
Right, welcome back, ladies and gentlemen. I hope you are ready for our second example. You will notice if you look at this problem, the equation of the hyperbola was not given to us. And that is the first question, that we must find this equation of the hyperbola, and then the others to follow. So let's start with this equation of the hyperbola. You will agree that to find the equation of the hyperbola, we need the asymptotes. And our asymptotes are x equal to 0 and y, what do I say? Yeah, x equal to 0 and y. No, let me try again. Sure. The break didn't do me well. X cuts at 2 and y cuts at 0. So that means the x-axis is an asymptote, and this one is the other asymptote. So we have our two asymptotes, the y equal to 0, because it cuts the y-axis at 0 and it cuts the x-axis at 2. Now, when we write down the equation of a over x plus p plus q, that is where we substitute the p and the q. Please tell your learners to be very careful when they substitute p. They sometimes in exams, they change the sign. They don't write it as x plus p. Some textbooks do it as well. They write it as x minus p, because they want to bring in that negative. But I don't think it's a very good idea. I think it's very confusing, and in any case to me. So we know the asymptote is at x equal to 2. So we just reverse the process, bring the 2 back, and we get x minus 2 is 0. So x is equal to 2. Now I solve it again. It was not necessary. So we can put x minus 2. Remember what we do? We take that, we put it equal to 0, and then we find x. And the q that we leave as it is, and that is, in this particular case, that will be 0, because the graph didn't move up and down. It only moved left and right. So now we need to find a. To find a, we need a point on the graph, and you notice there's a point given to us on this graph, which is at -1 on the y-axis. So we're going to substitute 0 minus 1 so that we can solve a. So we say -1 is equal to a over 0 minus 2. And if we multiply both sides with that -2, we get a is positive 2. So that means this equation is then 2 over x minus 2. The domain of G, domain and range of a hyperbola, always real numbers, excluding the asymptote. So this one again for domain, we say that x is an element of real numbers, but x can't be 2, because if x is equal to 2, it gives us a 0 denominator. So we exclude the 2 of the asymptote. Find the equation of S and axis of symmetry of G. Now, ladies and gentlemen, just to quickly go over this again, you hopefully still remember that a hyperbola has got 2 axes of symmetry. I'm not referring now to asymptotes, axis of symmetry. The one is, if I can just quickly make a drawing for you of the 2, maybe I can just do it here. If I just draw the basic graph, the one is here, and this is y equal to x plus b, and the other axis of symmetry goes here, and this is y equal to minus x plus q. So that is the 2 axes of symmetry that we have. And you will agree with me. You can look at both axes and you will see the graph, the graph is symmetrical about those lines. They ask us now to find a specific one, S. Now, this S1 that they ask us to find is this one. So that is the decreasing one. So that is the equation. So that is what your learners must know. They must know these 2 equations, and they must know sometimes they ask them for both. They do both. Sometimes they ask them for the positive gradient, then it's this one. Sometimes they ask them for a negative gradient, then it's this one. Or they put it in the drawing like they did here, and they must be able to say which one is which. So we're going to do y equal to minus x plus q, because that is where we expect what S will be. So all we now need to do is we need to substitute a point, and we can find the Q value, and the point is that one. So we always substitute the point where the 2 asymptotes meet, and that is the point 2, 0 for this graph. That is where the 2 asymptotes will intersect, because the other one will be there and that one is over there. So though your asymptotes will both meet where the asymptotes meet at the same point where the 2 axes of symmetry intersect. I now confused myself here, but let's substitute. So y is 0, and then I get minus 2 plus q. So you agree that q will be positive 2. So that means that equation will be minus x plus 2. Does that sound more or less correct? The negative tells us it's a negative gradient. Yes, that 2 tells us the y-intercept is at 2, and that looks correct to me as well, according to the drawing. Now they ask us to find the coordinates of A and B. Now, ladies and gentlemen, that is simultaneous equations. It is something that is lots of effort for the learners, because they must put the 2 graphs equal to one another. Now, if you don't mind, I just want to just put down a few pointers here, and not to write down everything, but we can equate these two functions at 5 minus x over 2 over x minus 2, and now we multiply with the LCD, put it in standard form, factorize, and your x values work out to 4, or x equal to negative 3, no, positive 3. 4 and 3. Those are the x values, and you can do notice from the graph both are positive. And then we substitute into the straight line is the easiest, the 4 in, and then we get the corresponding y values. If we substitute that into, where's the straight line, 5 minus x. So this will be 1, and 5 minus 3 will be 2. So point A is the 0.32, and point B is the 0.41. You will see that A is 3 and B will be the 4. So that's the 2 points where the 2 graphs will intersect. So if we look at the next one, they ask us for average gradient. Now that is pretty boring. You notice that they ask it between A and B. We have those two coordinates. We just calculated that. So we just use for average gradient, we use the same formula as gradient, and that is the change in y over change in x. And that gradient then works out to -1 if we use those values of A and B. In the next question, they say if y is equal to A over x plus b, is the reflection of g in the y-axis. Determine the values of A and B. So what they ask us here, they say that this graph is the reflection of G in the y-axis. So that means we must take the G graph, which we know because we found the equation of that G graph. Let me just find it quickly. That was the hyperbola, and here it is, y equal to 2 over x minus 2. So that is our gx graph. So if I can just maybe start there and say that gx is equal to 2 over x minus 2. Now what they ask us is, they say we must take this graph, this G, and we must reflect it in the y-axis. So that means we must find the G of minus x. You remember that page that we spoke about? Because if the x becomes negative, we reflect in the y-axis. So we must now apply this on G. So we will get 2 over minus x minus 2. But we don't want a negative with x below the line. So we will take that negative out as a common factor, and then we will put it with a numerator, and you will get x plus 2 below the line. So that will be the equation of y, minus 2 over x plus 2. Now they ask us to find A and B, so it's very important your learners must now write down that A is -2 and B is +2. And you agree, if we reflect this graph about the y-axis, you agree what we said before, we sort of change the quadrants, and that is why A must change sign. If you look at G, that's quite an interesting little question. I say here that if y is equal to the G of x plus p plus q, has vertical asymptote x equal to 4 and passes to the point 64, determine the values of p and q. So what they say to us here is that this is the graph y equal to, and something must happen to G. You will see there's a x plus p, G x plus p. So that means this G graph must move horizontally. And we can maybe try to find that, because that is what P will be. Now, this asymptote is currently at 2. They say to us the asymptote will be at 4. So do you notice that shift of 2 units to the right? So that means we can say 2 units to the right. That means that P is equal to -2. That P inside the bracket. That must be x minus 2. I hope you all agree with me. Because if I take the x minus 2, put it equal to 0, I get x is equal to 2. And that is the 2 that it must shift to the right. So that means we know what P is. So we can now go and say that y is equal to 2 over, that comes from the G graph, over x minus 4 plus the q. So you agree I didn't change the 2 because this graph only moved left and right and up and down. So the A value didn't change. So that is 2. I changed the P value from x minus 2 to x minus 4. and now we must find Q. Now to find Q, we need a point. And do we have a point to substitute? And the answer is, I think so. I think so. We most probably have a point. Where can we get a point that we can substitute? And it was given. Quite easy. The point given to us, the 6, 4. So we're going to say 4 is equal to 2 over x minus 4 plus q, but I didn't substitute that. So let me just fix that quickly. 4 is equal to 2 over 6 minus 4, because we want to solve for q. That is 6 minus 4 is 2 over 2 is 1. So it sounds to me like q, I think, will be 3. So that means this y then will be, well, they didn't ask us for the equation, but we can still write down the equation. 2 over x minus 6 plus 3. I think that will be the equation. What they wanted from us was P and Q, and we've got both of them. So that was an interesting thing, a little bit of reasoning here. Not the most easiest of questions in terms of transformations. So ladies and gentlemen, if you're okay with it, this next question is sort of almost similar to the previous one, but one difference is now the hyperbola equation given, but the straight line not given to you. So what I can maybe quickly do is just to give you this GX equation, and then we don't do the whole thing. They ask us for domain and range, the vertical asymptotes, we can read that. The vertical asymptote, I think it's x equal to 1, and then they want the length of CD. So those are x-intercepts. So point C is the point -2 and 0. And D is the point 80. So they ask us for the length of CD, and that will be 10 units, the 8 plus the 2. So just that we leave this question, and we hopefully, what I think we must maybe do is maybe to look at these inequalities, and at least that we do them for this particular one, because we didn't do any inequalities on the previous one. No, we didn't. So I think it's a good idea that if we look at these inequalities here. So we have all the values on the graph. So this is at -2, that was at 8. And we've got the asymptote here. This asymptote is at 1, and that asymptote is at 2. So that is, I think, the values we will need. The first question is fx less than 0. So we look at the hyperbola. And where is the hyperbola less than 0? That means below the x-axis. And you will notice that it only happens at one spot. And it's this spot here. But you notice there is an asymptote. So it is negative from -2 up to 1. This hyperbola is negative. So if we write it down, we will say -2 less equal to x. No, not equal to. There's no equal in the question, so that is my mistake. X greater than -2 and x less than 1, because there's an asymptote. So if there was an equal given to us, the -2 will get equal, but the 1 will not get the equal because it's an asymptote. So that was an easy one because we just look where the graph is below the x-axis. The next one, the one between the two functions. So let's draw our blue lines again. That is where the two graphs intersect. And you will agree it intersect here, it intersect at B, and there's also an asymptote. So we must now look at those intervals and see this value here is at 3 and that one is at 4 if we need those values. So where is the f greater than g? You will see that f is the hyperbola. Now, if we look at this blue line, this one, this is the one at 1, and we look to the left, do you agree that this is the G graph and this is the F graph, that G is greater than F because G is above F, and that is not what we want? So we must look at the next interval, which is from 1 to 3 for this interval, 1 to 3. 1 is an asymptote. It will not get an equal if this is the interval. Do you notice that there is F and there is G, and F is above G? So F is greater than G, F greater than G. So that we want. So I want to write that down. So I'm going to say this is from where does that happen? From 1, x greater than 1, less than 3. We just need to check. The 1 is an asymptote. It will never get an equal. There is an equal in the question. So the 3 will get an equal. And now we must look for maybe another solution. So the next one we look at is 3, from 3 to 4. Do you see G above F? G is the straight line, F is the parabola. G is above, like I said before, they changed around. And now we look from 4 to infinity. And you can see that is where F is and that is where G is. So F is above G from 4 to infinity. So we can say x greater equal to 4. And that's my solution for where fx is greater equal to gx. So let's look at the product. This product's got an equal. Remember what I said before, we want to draw the lines at the x-intercepts, but also we draw a line at the asymptote. So there's the one x-intercept, there's the other one. This one was 8. This x-intercept, I think, was at -2. And the asymptote was at 1. So we're going to draw a line at -2. We're going to draw a line at the asymptote, and we're going to draw a line at D. So that is where the graphs will change sign. We want to know negative. So that means we want different signs. So if we look from -2 to the left, you will agree with me that this straight line will continue there. And I must maybe just do it in the same color. And this hyperbola we can also extend. And then it is quite clear. If you look at these two graphs now, this is G and this one is F, and both are positive. Both are above the x-axis. If we look at -2 to the left, both are positive. So that means the product will be positive, and that is not what we want. So now we need to look at -2 up to 1, from -2 to 1. Can you see that graph is positive and this graph is negative? That is what we want. So let's write it down. So we will go from -2 less than x less than 1. That 1 is an asymptote. It does not get an equal. The question has an equal, so the -2 must get an equal. Or is there another one? So now we will look at 1 to 8. And do you notice both are positive? And then we look at 8 to infinity. And f is above, g is below. So f is positive, g is negative, the product is negative. So that solution we are looking for, and that is x greater and equal to 8, because equal is included in the question. So that was just the inequalities of this question that we didn't do everything yet. I want to jump into this question on two graphs, and they are both quite interesting in the sense that they are both exponential, but they're not straightforward exponential graphs. If you look at fx, for example, this graph is negative 2 to the x plus 4. It is extremely important that your learners must realize the negative 2, that negative is not part of the exponent. It is a negative 2 to the x, because our base can never be 2. Negative 2. We do get bases of negative, but it's not in our syllabus. We only do it at tertiary, and that is where we get oscillating functions. So that is now functions, for instance, like minus 2 to the x. And please don't discuss it with the learners. If you have a high flyer who wants to know, show them. But just do it with a table, and you will notice you will get a point there, a point down, point there, point down here. And we can't really draw these graphs because they are discrete functions. So we don't work with negative exponents. So a long story, but just to explain that. So we want to look at these two graphs. There's the one, and that is the other equation. This one is given, this one's got a q. So that means we need to know where that will be. So they ask us to find that q value, and that is your gx. So we say y equal to 2 to the x plus 1 plus the q. And to find it, the best thing is, because that is the g graph, this is g, 0, 0 is on that graph. So we just substitute 0, 0 in. So we get 0 is equal to 2 to the 0 plus 1 plus the q. So that means q is equal to 2 to the 1, take it across, negative 2. So that's what they ask us for the value of q. Then they say write down the equation of PQ. It is that equation, that is the asymptote, and they also ask for RS. Now, the big question is, can you find them? I don't think it's too difficult. You agree for the F graph, or PQ, that is the asymptote of the F graph. You look at F, you will see that graph moved 4 units up. The asymptote used to be at 0. Now it is at 4, so you will agree that PQ equation is y equal to 4. And then we do the same with RS. And RS is the asymptote of the F graph, and we just found that Q value, and that equation is y equal to negative 2, because this is at negative 2, and that is at 4. So quite nice, these questions, I think. Then they ask us for the range of f, the range, that is the y values. So do you agree it is 4 is the maximum and it goes to negative infinity? So we will say y is less than 4, where y is an element of real numbers. We don't include it, the 4, because it's an asymptote. We can write it in interval notation as well, where we say it is negative infinity up to 4, both open brackets. All right, then they ask us for the coordinates of A, and that is where we put the two graphs equal. So this 2 to the x plus 1 minus 2 is equal to minus 2 to the x plus 4. And we move the constants to one side, the variables to the left, and we can solve them easily. X is equal to 1 and y is equal to 2. So that A is the point 1, 2. For the B coordinate, that is the x-intercept, and that is where we let y equal to 0, and then x works out to 2, so the B coordinate will be 2, 0. So that value is 2. And then C is the y-intercept of the F graph. And if we find the y-intercept, we substitute x with 0, and we will get y is equal to 3. So that point C is the point 0 and 3. So there we have those coordinates if we need it for later questions. They say if OD is 1 unit, find the length of EF. So they gave us the coordinates of point D. They say the length is 1 unit, so the coordinates is -1 and 0. And that means we must now find the two corresponding y values, the y value for F and the y value for G. Now, if we find the F of the -1, we get 7/2. And if we find the G of -1, we will get -1. So that means the length of EF will be the sum of these two, so 7/2 plus 1, and that is 9/2 units. Because the one y value was negative, so we just take it as a positive distance. So that was just for that length. Now, ladies and gentlemen, I have a little star question here. And they are questions that is at least a level 3. One can maybe sometimes even argue closer to a level 4, but you can maybe tell me once we do this one. I explain how the graph of G can be transformed to produce the graph of F. So they want us to explain how this can be done. So Gx is 2 to the x plus 1 minus 2, and Fx is the minus 2 to the x plus the 4. So they say, how can G be transformed to produce the graph of F? So that means we must start with the G graph. And we must transform this graph to get F. And the first thing we're going to do is we're going to reflect it, because that is where that negative comes from, that is with the 2 to the x. So we will reflect this graph. And then, so before I write the rest, I'm going to say plus 2, but that you must first see why it is plus 2. Because if I take this negative into the bracket, I get minus 2 to the x plus 1 plus 2, you see, and there's a 4. That is why I said this is a plus 2. I must add 2 to it. That is the plus 2. Now, the big question is, I left out something here. Yeah. This graph is something I left out, ladies and gentlemen. Let me just go back. First of all, I want that negative. So I reflect it. That is where that negative comes from. Do you notice this x doesn't have any p value? This one is a plus 1. So I hope you will agree that we're going to say in the bracket a minus 1 there, because we want to change it to negative 2 to the x plus the 4. And you will agree this is fx. So my 3 transformations, a reflection, that was the first one, the reflection. Secondly, it was the horizontal shift of 1 unit. and then a vertical shift of 2 units. And that will produce the graph of fx. A pretty interesting question, if I may say so. So, ladies and gentlemen, we have an inequality on these ones. They say, where is the product negative? Now, the product, the sign will change at x-intercepts. So let's see where the x-intercepts are. At B is an x-intercept, and at 0 at the origin there's an x-intercept. So let's have a look. We want the product to be negative. So one graph must be positive, one must be negative. If we look to the left of 0, can you see this graph is positive, this graph is negative? We want that. So we're going to say x is less than 0. There is no equal there, so we don't put the equal in. Or let's see if there's another one. Then we look between 0 and B. Both graphs are positive. And then we look at B to infinity. G is positive, F is negative. So we want that as well. And that point B is at 2. So it is x greater than 2. So because that point is at 2. So all x values greater than 2, x less than 0. So ladies and gentlemen, that is the question on the 2 exponentials. Yes, another one which is pretty interesting, and that is the graph of an exponential combined with a parabola in the APQ form. They first of all ask us for the turning point, which I think is pretty easy for all of us. We can just read it, and that is P is the point. The X is, you put a bracket to 0, you agree with me, it is 2, and Y will be 1. They ask for the range of F. So we need that value, and that is given to us as 1. So that is the asymptote. So the range of F, that is the exponential, is Y greater than 1. Can't be equal. And then for G, it's from the turning point to negative infinity. So that is Y less equal to 1. That gets an equal. What is the domain of F? And that is X, an element of R. Domain is always real numbers. And now they ask us to find the values of A, B, and T. And B is that base T in the formula, and A. So they basically ask us to find the full equation of the parabola and the exponential. So let's start with the hyperbola. I think that is the easier one to do. And it's A over x minus 2 squared plus 1. And the only thing we want is we need a point. And we have 0, 0. And if you put 0, 0 in to this one, 0 is equal to A, 0 minus 2 squared plus 1. Then you get that A is negative a quarter. And that is what they ask us. So there we have A. So we've got the equation of the parabola now. Secondly, we must look at our F graph, and that is fx equal to b to the x plus t. Now b is the base, and we know that base will be greater than 1 because it's increasing. But t, we need to know what the shift was of this graph, because t represents a horizontal shift. And I hope you agree with me that is a 1 unit shift, because the asymptote normally at 0, now it is at y equal to 1. So we can clearly say that it means t will be 1. So that means that y is equal to b to the x plus 1. And now we substitute a point. And what is the point we will substitute that we have? And do we have a point on this one? Let me just have a look. Okay, there it is. That was a little catch. Do you notice that PQ equal to 9 units? This one. So that distance, 9 units. This is at 9 units. So I think you will agree with me that Y value will be 10. And this X value is the X value of the turning point is at 2. So this coordinate we can substitute is X2 and Y is 10. That was a little bit of a tricky one because they needed to look at that distance to get it. And now we can solve B. So we substitute 2 and 10. So we say 10 is equal to B squared plus 1. Take the 1 across is 9. You find the square root. So B is equal to 3. Not plus minus 3 because B is a base. B must be 3. So there we have all the variables. We found, first of all, we found A as minus a quarter, B as 3, and T as 1. So now we have all the values. So now we can find these lengths quickly. They ask for the length of OC. That is just the y-intercept. Now the y-intercept of that exponential, which was 3 to the x plus 1. So that is y is equal to 3 to the x plus 1. I think that is the equation. If you substitute x with naught, you get 3 to the 0 is 1 plus 1 is 2. So that point is at 2. So the coordinates of C will be 0, 2. So that means OC equal to 2 units.
Jörg?
Yes.
There was a question. Someone asked, could learners also find C?
I'm not so sure what C they are referring to.
Rahima, maybe you can just elaborate on your question, then I'll ask Jörg again. Okay, Jörg, I think continue. I'll wait for Rahima to type and then
Okay.
I'll let you know again.
Yes, 100%. Okay, so I'm busy with the length of OA. O is at 0. That is the other x-intercept. So we must take the parabola now. And the equation of the parabola is y equal to minus a quarter. And it was x minus 2 squared, I think, plus 1. And if we want the x-intercepts, you let y equal to 0, and you will get 0 and 4. So that a value will be at 4. So we will get x is equal to 0 or x is equal to 4. So that means OA equal to 4 units. That's a pretty easy one. It's just the x-intercepts of the parabola. Let's just quickly look at number 6, because I still need some time on the nature of roots before we finish. The graph of Sx is equal to c to the x plus q is produced by reflecting f in the y-axis. So let's start with our f graph first. So this Sx graph is c to the x plus q. That is the graph. They say the graph of this is produced by reflecting f in the y-axis. So the graph of this is produced by reflecting f in the y-axis and then shifting the results downwards. S passes through the origin. Determine the values of C and Q. They want this C and Q. All right. Now the big question is, that that f function is y equal to 3 to the x plus 1. Now, ladies and gentlemen, if I reflect this graph in the y-axis, this f graph, do you agree it becomes decreasing? So that means c will be a third, because it must be decreasing. Not 3 anymore, but a third now, because it's 3 to the minus x, and this is 3 to the x. And then they told us that it's going to pass through the origin. So we take the origin now, 0, 0, and we substitute this into Sx. So 0, c is a third to the 0 plus the q. And now a third to the 0 is 1, so q is equal to minus 1. So now Sx will be a third to the x minus 1. And I think you will agree that it was reflected because of the 3 that became a third. It moved also vertically. They told us so. There's a shifting downwards. You will see it was at 1, now it is down at minus 1. So there's a movement down of 2 units.
Yes.
Yes.
Okay, so Rahima asked in the previous question, so I think it's, yeah, that instead of using PQ and subbing the coordinates for Q, could they find the coordinates of C? Understanding that there is a vertical shift of 1 and the y-intercept shifted 1 unit up.
Is it this one? Because there's no C here. She refers to C, but I don't know which question. Maybe she can be a little bit more specific.
Question
Which
4.
question?
4, I think 4. Just go a little bit, just go to the next one.
Back or to the front?
No, forward. Another one, forward. Forward. No, I think it's that one there. She also said C is the y-intercept of F. Example 5, question 4.
Values of A, B, and T. For A, I think that is quite obvious. We just needed to substitute a point, and that gives us A. So I think a question must be part of this to find B and T, but you said something she referred to C. But I don't know, is the C, does she refer to this C as the y-intercept on the drawing, or what? It's extremely difficult to answer.
You want me to read the question again?
Please, yeah.
Okay, in the previous question, that 4, instead of using PQ and subbing the coordinates of Q, could they find the coordinates of C? In brackets, understanding that there is a vertical shift of 1 and the y-intercept shifted 1 unit up.
That last part makes perfectly sense, but I don't understand the PQ. Only PQ is this distance. Okay, no, I think I got the question. It's just quite difficult to get a question. I think what she asked was where I explained how to find the 10. And I use that PQ as 9 units plus the 1 unit here that gives you 10. And I'm not so sure. She said this graph moved up. I agree. It is, the asymptote is at 1 and the C is at 2 now. But I'm not sure how, I don't know how to explain it, honestly. Maybe, Rizal, maybe we can ask her to put her mic on that she can tell me and explain to me what she is saying. It is very difficult if she type it and for me to understand.
Okay, shall we continue and maybe come back to this after the webinar when you ask for, you know, the list of questions?
That can work.
Okay.
All right, let's do that. Please just remind me that we just get back to that because I have another question that I still want to do before we finish.
Okay.
All right, ladies and gentlemen, this one is a vertical distance PQ. We've done one like that. So you know what we do with questions like this. We say PQ, we take the top one minus the bottom. Top one is the straight line. 2x minus 7, subtract x squared minus 6x minus 7. Put it in standard form. Then we use the little formula of x equal to minus b over 2a. That's what I like to use to find like the axis of symmetry and to substitute back into PQ to find the length. And the x value works out to 4 and PQ is then 16 units. So it's a question that they ask in grade 11 and that is how we will look at it. In grade 12, they ask the same question, but they ask it in calculus. And then the maximum length we also subtract, but then we use differentiation to find the maximum length. All right, so I don't want to spend more time on that one. Ladies and gentlemen, we have still a few questions, but I would like to finish off with this one on nature of roots. The others are just more of the same kinds of questions that I just put in too many, but it can't do harm. You can try those. I want to look at these nature of roots. And ladies and gentlemen, this is quite important. The exam panel said they will test this in every exam. So the first question, quite easy. We have the drawing of the parabola. We have the x-intercepts, we have the turning point, we've got the y-intercept. They say how many roots. Now, you know roots, we refer to the x-intercepts here, and there's a clear 2 of them. Now I want you to look at number B, but please look at the notation. This is very important, this notation. They say if f of x plus b is 0, as 1 negative root and 1 positive root, determine the values of p. Now, this notation tells us that this parabola must move to the left because the roots are 1 and 3 at the moment. We want with this root to be negative, but this one must stay positive. So we want 1 negative root, 1 positive root. So you agree we must shift the graph 1 unit to the left. Now, if we shift exactly 1 unit to the left, then this 1 is at 0, and that 3 will be at 2. So it will be 0 and 2. You will agree it is not 1 negative and 1 positive. 1 is 0 and 1 is positive. So you agree we must shift it more than 1. Now, learners always tells me, if I say more than 1, they say 2. And I always ask them, what about 1.5? What about 1 1/4? We have many values before we get to 2. So the important thing is P must move more than 1 unit. P must move more than 1 unit. But it must move less than 3 units. Because if it moves more than 3, or if it moves 3, then this point, this one, will be at 0. So I can't move, I think I said more than 1, but less than 3. Yeah, less than 3. I don't know what I said. But in any case, I can't move more than 3. If I move more than 3, both are negative. If I move 3, one is negative, one is 0. I must move less than 3. So P is less than 3, but greater than 1. So that is just this horizontal shift. They can ask and say, you want both roots to be negative. Then you must move it more than 3 units to the left. Now, in the next one, they say, for which values of k does fx equal to k have 2 distinct real roots? Now, ladies and gentlemen, the moment they refer to distinct real roots, they talk about 2 roots. 2 unequal roots is what we refer to. So there's the parabola. Fx is the equation of the parabola, and they put the parabola equation equal to k. So that means we've got the parabola equation, and we've got another one of y equal to k. So y equal to k is this one, and that's the parabola. And do you notice there are 2 solutions, 2 roots? The question is, what must k be so that these roots will be 2 unequal roots? And I think you agree with me. If I take this line anywhere, I will get it. I will get the 2 unequal roots. But if I draw it at the turning point, I will only get 1 root. If I draw the line below the turning point, I will get no roots. So we have distinct real roots, we have equal roots, we have non-real roots. So we must draw the line, this k line, above the turning point. And the turning point is at y equal to -1. So what must we do? We must say k, because they ask us for k, must be greater than -1. So this line of k must be drawn above -1. So we can draw it there, doesn't matter. But we can't draw it at the turning point, and then it's equal roots, and then no real roots, or non-real. So you notice D is exactly the next one. They say equal roots. The same one, but now they put it equal to, I put it equal to P. So you agree now we need to draw the line at the turning point, because now there's only one solution. So that is k equal to -1. When we look at the last question, this one they phrased a little bit differently. I tried to give different ways that they can test this. Now, if you look at this last question, it is not the parabola equal to k or p or t. Do you notice that in the parabola's equation was x squared minus 4x plus 3? But now instead of the 3, they now wrote it as x squared minus 4x plus t equal to 0. So this t is now instead of the y-intercept. So they ask us now, what will happen to the y-intercept if there are no roots? So let's first focus on no roots. What must happen to this parabola so that there are no roots? I hope you agree that this parabola must move just to above the x-axis, not on the x-axis. So if we move it 1 unit up, the roots are equal. But if we move it more than 1 up, there are no roots. Now, if I move more than 1, what will happen to the y-intercept? It is currently at 3. Do you agree the y-intercept will be more than 4? Because it's 3 plus more than 1. So that means t must be greater than 4. That t represents the y-intercept. I hope that makes sense. It is an awkward one, but please look at it carefully. And these questions on nature of roots. There are a few questions left, one on 2 exponentials again, and then 2 sort of real life questions, which is not very difficult. I put this one in. It's not a very difficult question, but it's a real life question on a parabola. Quite interesting, a little bit different. And then this particular one, and if you don't mind, can I quickly just show you the first part? This function is a level 4 question. You don't need to do it with your learners if you don't want to. It is a high level question. So I've got fx. I just quickly want to show you something. This graph's got a gap. We call it a gap. So this graph is not continuous. Now they will ask you to find b, the coordinates. That is the third question. They want a and so on. So what you need to realize with this question, that the numerator is the difference of squares. So that is 2. I'm now rushing a little bit, and now everything is a mess. So I've got 2 to the 2x minus 4 over 2 to the x minus 2. And then 2 to the x minus 2, and then I can factorize this. And they cancel, and we get 2 to the x plus 2. So this is the equation of f, excluding b. And they say find the coordinates of a. Now, to find the coordinates of a is now easy. You substitute x with 0, and that will give you that a value. And the coordinates of a, if you substitute x with 0, you get 2 to the 0 is 1 plus 2 will be 3. So the coordinates of a is 0, 3. The horizontal asymptote, do you notice that the graph moved 2 units up? So that is y equal to 2. Coordinates of b, that is where the denominator is 0. Very important to find b, because that's the undefined value. So we get 2 to the x is 2, so that means x is equal to 1. And we substitute it back to find b, and if you substitute it back into that equation, x is 1, you will get 4. So that coordinate is at 1 and 4. Then it's domain and range. Those things are pretty straightforward. Ladies and gentlemen, thank you so much. I went 9 minutes over time. I hope you can forgive me. But with that, I'm going to stop here. Unless there are questions, if people then are happy and they want to leave, you're welcome, and maybe we can quickly sort out that one question. I really appreciate that you are prepared to listen to me, and that I'm not talking here to myself. At least I see there are a lot of people, and I really enjoyed to be with you this afternoon. Have a great evening. All of the best until we see one another again. Goodbye.
Geert, thank you so much. We really appreciate it. As always, thank you for taking the time. All the teachers really enjoy it, and looking forward to the next webinar. I have tried opening up Rahima's mic. Rahima, are you still there with us?
Yes, I am. I understood I was asking, because we used PQ, and we had to find the coordinates of Q, and I was looking at C. I seen C first. I didn't see PQ. That's why I asked the question. But no, I'm clarified now, because C is the y-intercept, and then to solve for B, it will just cancel B out.
I don't understand. You mean what B?
It was to find the values of A, B, and T. I believe
Yes.
it was A, B. Yes.
Yes.
So if you substitute the coordinates of C, which was, I think it was 0,
0, 2.
2, then I think it was going to cancel something out. I can't recall.
Yeah, it sometimes happens that way. That is why we needed that Q coordinates. And that
Yes.
was sort of the catch in the question, to notice that PQ is 9, but P is already at 1, and the length is 9, so Q will be at 10. So because we wanted that Y value, so
Yes.
that we can substitute a point to solve for B. No, I get it now what you are trying to say. So it makes sense why it would have cancelled if you use that 0.2.
Yes. No. Thank you so much. Appreciate it.
You are more than welcome. As long as you're happy, then I'm happy.
Thank you.
Have a good afternoon.
You too.
Thank you so much, everyone.
Someone just asked for answers. They
Yes.
put a question up. I can quickly do that if there's someone who wants. If you can just show me, it's maybe something I left out. Can you maybe see it? It's gone on my side now, Roselle. I just noticed someone said he wants an answer.
Is it possible for you to give the answers of example 8 and 9, please?
Yeah, it is quite a lot. I can try, but it is not so straightforward. I would rather suggest that the person who asks for these answers must get the textbook, because then you will get the answers. I don't mind, but I can try, but it's going to take a while. To do both of these is definitely another 20 minutes.
Jeff, is it not a possibility that we can maybe do a short video on that at a later stage and then also share this with the attendees?
Sure. Video is extremely difficult because I'm quite alone. You need someone to assist you in making a video.
Yeah.
I don't have anyone with me.
Yeah. But like you say, maybe if they just refer to the textbook.
The only thing I can think, if a person wants the answers, is they don't have the textbook. And I will suggest, because these I took from the textbook, and for that simple reason, if we can't finish everything, then we can leave some of them. Now, there's another question. Someone asked, I must explain a question. Rizal, can you see that?
Can you explain example 7E?
Oh, this last one.
Yeah.
Yes, that we can do. All right. This one, number E, quite different to, like I said, from C and D. In C, you can see it is the parabola, fx is equal to k. Parabola equal to p. But now it's not the full parabola. It's only the first two terms, but instead of the 3 as y-intercept, they now put a t in there. And the question now is that the roots must be non-real. So for the roots to be non-real, it means this parabola must move that 1 unit up so that this graph does not touch the x-axis. As you can see, there are no roots now. This graph and the x-axis does not intersect. So that is the whole thing, the whole argument. How far must you move this graph up so that it will be above the x-axis? And the answer is we must move it more than 1 unit. So we can't give an exact value because it can be 1,1, 1,01. There are millions, infinite number. So that's why I say we move it more than 1. If you move it 1 unit, it's on the x-axis. We must move it more than 1 unit. But now they say they want to know if that is now to get the roots non-real. Now, once you've done that, what will happen to t? Because that's what they ask us. What will t be? Now, if you look at the equation, t is in the place of the y-intercept. So they say if there are no roots, like we've got it now on this blue one, what can you say about t? What will the y-intercept be? And t will be greater than 4. Because t is currently at 3 when the turning point was at -1. If I move it up more than 1, this will move more than 4. So it will not be at 4, but it will be more than 4. Because this graph can go even higher. So it can be 5, 6, 7, whatever. I hope that helps a little bit. Pleasure. I don't know if there's anyone else who's got a question which I can try to answer.
It looks like that's it here.
All right. Ladies and gentlemen, then I say goodbye to you. Enjoy your afternoon, and then we see one another hopefully in the near future. Keep well, all of the best.
Thank you again, Jörg. And yes, we will share the recording soon. Be on the lookout for that. And if you have not received the notes, please send an email to anita@mindaction.co.za, and Anita will send the notes to you. Thank you, everyone. Have a good evening. Till later.